Welcome to Supplement Saturday. Vitamin B12 is probably one of the most recognizable vitamins in the supplement world. You'll see it in multivitamins, energy formulations, tablets, sprays, and injections. And if you've ever felt tired, there's a good chance somebody has suggested B12. That association isn't completely misplaced. Vitamin B12 contributes to normal energy-yielding metabolism. But describing B12 simply as an energy vitamin misses most of what makes this nutrient so fascinating. B12 is involved in normal red blood cell formation. It contributes to normal nervous system function. It participates in DNA synthesis and several important biochemical reactions throughout the body. And unlike many nutrients, obtaining B12 is only the beginning of the story. Your body also has to successfully absorb it. That journey is what we're exploring today. What exactly is vitamin B12? Why does the body need it? Where do we obtain it? Why can some people eat foods containing B12 and still develop deficiency? Who may particularly benefit from supplementation? And where does B12 fit within an evidence-informed healthy lifestyle? Let's start with the vitamin itself. Vitamin B12 is also known as cobalamin. It's a water-soluble vitamin containing the mineral cobalt, which is where the name cobalamin comes from. The human body needs only relatively small amounts, but those amounts are essential. One important role involves red blood cells. Red blood cells carry oxygen around the body. B12 is required for normal red blood cell formation, and inadequate B12 can interfere with this process. Another major role involves the nervous system. Vitamin B12 contributes to maintaining normal neurological function, which is why significant deficiency can sometimes produce symptoms such as numbness, tingling, problems with balance, or cognitive changes. B12 is also involved in DNA synthesis and normal cellular metabolism. So when we describe B12 as the energy vitamin, we're describing only one small part of the much larger biological story. Now let's follow B12 through the body. Imagine eating a meal containing fish, eggs, meat, or dairy. The B12 within those foods is generally bound to protein. Your digestive system cannot simply absorb it immediately. First, digestion has to release the vitamin from the food protein. Acid and digestive enzymes in the stomach help begin that process. B12 then interacts with different binding proteins as it moves through the digestive tract. Eventually, it binds to a particularly important protein called intrinsic factor. Intrinsic factor is produced by specialized cells in the stomach. You can think of it almost like a biological escort. It binds to B12 and helps carry it through the digestive system until the complex reaches the final part of the small intestine called the terminal ileum. Their specialized receptors allow B12 to be absorbed. And this complicated journey explains something extremely important. Eating B12 and absorbing B12 are not necessarily the same thing. That distinction becomes particularly relevant when we talk about deficiency. Let's begin with diet. Vitamin B12 occurs naturally predominantly in animal-derived foods. Meat can provide B12. Fish and shellfish can provide B12. Eggs and dairy products can contribute B12 as well. Some foods are also fortified with B12. Fortification becomes particularly important for people following dietary patterns that contain little or no animal-derived food. People following a vegan diet, for example, generally need a reliable source of vitamin B12 through fortified foods or supplementation. And this is a perfect example of why I don't believe supplements and healthy food should be presented as opponents. Sometimes supplementation is simply the most practical and reliable way of meeting a nutritional requirement within someone's chosen dietary pattern. But diet is only one part of the B12 story. Absorption can change too. As some people grow older, changes within the stomach can make it more difficult to release naturally occurring B12 from food. Certain gastrointestinal conditions can interfere with absorption. Surgery involving parts of the stomach or small intestine can affect the process. Some medications can also influence B12 status over time. And then we have a particularly important condition called pernicious anemia. Pernicious anemia is an autoimmune condition. The immune system interferes with the cells or processes necessary for producing functional intrinsic factor. Remember our biological escort? Without adequate intrinsic factor, normal absorption of dietary B12 becomes extremely difficult. In this situation, simply telling somebody to eat more B12-rich food doesn't solve the underlying problem. The issue isn't necessarily what they're eating. The issue is absorption. An appropriate B12 treatment becomes medically important. This is where supplementation moves beyond the idea of an optional wellness product. For some individuals, ensuring adequate B12 through supplementation or prescribed treatment can be essential. Now let's return to energy. Suppose somebody has been feeling exhausted for several months. They see B12 marketed for energy and think, perhaps I just need a B12 supplement. Could B12 be relevant? Possibly, but fatigue has many potential causes. Inadequate B12 is one possibility. Iron deficiency is another. Sleep deprivation can cause fatigue. Thyroid disorders can contribute. Some medications can contribute. Stress, illness, and many other medical or lifestyle factors may be involved. So rather than assuming fatigue means low B12, persistent or unexplained symptoms deserve appropriate assessment. If B12 deficiency is identified, correcting it matters. But if B12 status is already adequate, taking increasingly large amounts shouldn't automatically be expected to produce increasingly large amounts of energy. This illustrates an important principle in nutrition. A nutrient being essential doesn't mean more is always better. Water is essential, protein is essential, vitamins are essential, but biological systems generally function around appropriate amounts, not unlimited amounts. This doesn't make B12 supplementation unnecessary. It simply means the reason for supplementation matters, and that brings us to one of my favorite frameworks for Supplement Saturday: mechanism, evidence, context. Mechanism asks, what does B12 actually do? We've already established that it contributes to normal red blood cell formation, nervous system function, DNA synthesis, and energy-yielding metabolism. Evidence asks, what happens when B12 intake or absorption is inadequate, and what happens when we correct that problem? Here, the importance of adequate B12 is very well established. Context then asks, who is the person in front of us? What do they eat? How old are they? Do they have gastrointestinal conditions? Have they undergone surgery? Are they taking medications that could affect B12 status? Are they following a vegan diet? Is there a diagnosed deficiency or absorption problem? That third question, context, is often where intelligent supplementation begins. There's another interesting feature of B12. Unlike many water-soluble vitamins, the body can store significant amounts of it, particularly in the liver. Because of those stores, inadequate intake doesn't necessarily produce symptoms immediately. Deficiency can sometimes develop gradually over a considerable period. And this matters because neurological problems associated with significant B12 deficiency can become serious. Symptoms may include numbness or tingling in the hands or feet, difficulty with balance, cognitive changes, and other neurological problems. Not everybody with B12 deficiency will experience the same symptoms. And importantly, neurological manifestations can occur even without the classic picture of anemia. That's another reason self-diagnosing B12 deficiency based on tiredness alone isn't ideal. Appropriate clinical assessment and, where indicated, blood testing can help establish what's actually happening. Now let's talk briefly about supplements themselves. Vitamin B12 supplements come in several forms. You'll commonly see names such as cyanocobalamin and methylcobalamin. There are also different delivery methods, including tablets, sublingual products, and injections. It's easy for supplement marketing to make one form sound universally superior, but the appropriate form, dose, and route depend on why B12 is being used. For routine dietary supplementation, one approach may be appropriate. For confirmed deficiency, another may be required, and where significant malabsorption or pernicious anemia is present, healthcare professionals may recommend specific treatment strategies. This is precisely why personalized guidance matters. The question isn't simply which B12 supplement is best. The better question is, why does this individual need B12? And what is the most appropriate way of meeting that need? That's a very different conversation, and it's much more useful. There's also a broader lifestyle lesson here. Supplements can be valuable tools. Food provides the nutritional foundation, but neither exists separately from the rest of our health. Someone can take an excellent supplement while consistently sleeping 4 hours a night. Someone can eat nutrient-rich foods while remaining almost completely sedentary. Someone can exercise regularly while ignoring persistent symptoms that deserve medical assessment. Health doesn't operate in isolated compartments. Nutrition, supplementation, movement, sleep, recovery, stress management, and appropriate healthcare all interact. That's why I increasingly like thinking about health as a system. Vitamin B12 gives us a beautiful example. Food matters, absorption matters, physiology matters, individual circumstances matter, and supplementation can matter enormously when it's appropriate. So what should you remember from today's discussion? Vitamin B12 is much more than an energy vitamin. It is an essential nutrient involved in normal red blood cell formation, DNA synthesis, nervous system function, and normal energy yielding metabolism. We obtain it naturally mainly from animal-derived foods and from fortified foods, while supplementation provides another important source. But B12 has a particularly complicated absorption process involving the stomach, intrinsic factor, and the small intestine. That means somebody's B12 status isn't determined by diet alone. People following vegan diets require a reliable B12 source. Some older adults may have difficulty absorbing food-bound B12. Certain gastrointestinal conditions, surgeries, and medications can influence B12 status, and conditions such as pernicious anemia can severely interfere with normal absorption. For those individuals, supplementation or medical treatment may be particularly important. And perhaps most importantly, we don't need to approach B12 divided or supplements generally from a position of either enthusiasm or skepticism. We can approach them with understanding. What is the mechanism? What does the evidence tell us? What is the individual's context? Then we make an informed decision. That is the philosophy behind Supplement Saturday. Not telling everyone to take the same supplement, not telling everyone they don't need supplements, but helping people understand the science well enough to ask better questions about their own health. If you're experiencing persistent fatigue, neurological symptoms, or other unexplained changes, don't simply assume you need B12. Appropriate healthcare assessment can help identify the underlying cause. And if you're considering vitamin B12 supplementation and you're unsure where it fits within your individual health journey, reach out to Coach Kwanz for personalized guidance. Thank you for joining me for Supplement Saturday. For daily science-backed health insights, follow or DM me, Coach Kwanz.